But just wanted to go ahead and kick it off here. Today we've got Dr. Mary Lusk. She's at the Gulf Coast Research and Education Center up in Hillsborough County near Tampa. And she's also a faculty member for the Soil, Water, and Ecosystem Science Department at UF. And we oftentimes think about, like our practices and that happen in yards and landscapes. And today she's going to talk about how those are tied to water, like with throughout the state. So with that, further ado, I'm passing off here to Dr. Lusk.
All right, thank you. Thanks for letting me be a part of your webinar today. I'm glad that you do this every month. This is exciting and what a good audience. So again, thanks. Yeah, so I'm talking today primarily about sources of nutrients to urban waters. And so nutrients, of course, would be nitrogen and phosphorus. And we're very concerned about those in our urban landscapes in Florida, but also in other places throughout the world, because nitrogen and phosphorus are the chemical elements that many times phytoplankton and algae respond to in our surface water bodies, and excess levels of nitrogen and phosphorus can cause the harmful algal blooms that we're really concerned about in the state and in other parts of the world as well. So things like our cyanobacteria blooms and our red tides, all of that are tied to excess levels of nutrients in our waters. And so a really important question becomes, where do those nutrients come from? Because we need to know where they come from so that we can manage them. And I always say they come from many places, and we need to remember that. It's easy to point fingers. I think in Florida, sometimes they see that. We get different groups kind of pointing fingers at other groups, but we all have a piece of the pie. And today I'm going to focus on a couple sources that are prevalent in urban watersheds and talk about some implications of that and how we can manage that. And this first part is just based on tracking non-point source nutrient pollution. So by point source, of course, we mean nutrients that come from very distinct things like a wastewater treatment plant. But non-point source are all those sort of non-distinct things like urban lawns and sidewalks and streets, where everything just becomes a mixture of lots of different sources. So when we have a non-point source solution like that, how do we figure out where the nutrients are coming from? And it's important to us to do this kind of work. And I think you guys intuitively all understand this, but what we do at our urban lawns and in our urban landscapes, any nutrient or other contaminant that's on those lawn and urban landscape surfaces can end up in stormwater runoff and stormwater ponds. And those ponds and stormwater infrastructure is often connected to downstream water bodies like rivers and bays and estuaries. And it's just a continuum of flow there. So anything we do at the landscape level on our lawns and our urban green spaces, there's a connection all the way downstream to our bays and our oceans and coastal waters. And that's why we need to be careful about how we use chemicals and different things, nutrients in our urban landscapes. So I've got a picture here of some sources of nutrients in urban landscapes, and you can kind of see all the potentials here. And just following the numbers, I'm going to go through and talk about those a little bit. Number one is under the clouds, and it's the rainfall coming down. And it's something that a lot of times we don't recognize, but just the atmosphere and rainfall itself can be a source of nutrients, particularly nitrogen. And so what do we do about rainfall? It's just that's our nitrogen that's just in the rainfall, right? We can't control that so much. There are some things that we can do, and we'll talk about that a little bit as I get through the talk today. Number two, there beside the dog, pet waste, certainly a source. Where's number three on my list? Oh, number three down here is a septic system. And I don't have a lot of information today in my talk about septic systems. I do some work on septic systems. So if you're interested in that, shoot me an email later. But definitely they are a source of nitrogen in many of our landscapes, particularly in our spring sheds in a lot of areas of South Florida. So definitely something to be aware of. And we've got some new legislation in the state that's making us tackle that in ways that we never have before. So if you are interested in that, again, please just let me know. We can talk about that some more. Um, 4 microbial processes, 5, we got a guy here putting fertilizer down, and 6, the guy cutting his grass. Certainly things like fertilizer and grass clippings can be sources. 7 is the wastewater treatment plant here, and so it's treating wastewater, and in many times in many places in Florida, that treated wastewater is sent back to communities for reuse. So it's used as reclaimed water to irrigate our urban landscapes or to irrigate golf courses. And that reclaimed water definitely has elevated levels of nitrogen and phosphorus in it. And I'll talk about that a little bit today as well. And then, the far left side, we see the consequences of all of that. All of these sources of nutrients moving towards receiving waters and leading to our problems like eutrophication and harmful algal blooms. And again, just pointing out the idea here that we all have a piece of the pie. We can't point fingers. It's somehow we're, in one way or another, we're probably all participating in one or more of these sources of nutrients in urban landscapes. So that was a cartoon version. I'm going to show some real examples now. I took all these pictures. I'm going to show 6 or 7 pictures here. These are pictures I took in my Tampa Bay area urban neighborhood over the course of like a 10-minute period. So I just walked through my neighborhood and I found all these sources very quickly. And the first one here is I see this a lot for some reason in the area where I live. So this is the roof downspout connected to the driveway, which then just flows to the street, right? And flows to the stormwater runoff, to the pond, to the Tampa Bay. And the problem here is all that roof runoff. Again, remember rainfall can be just a source of nitrogen itself. So we've got the rainfall with nitrogen and phosphorus in it. And then it's interacting with things on the roof like dead bugs and leaves and all that stuff. So it's accumulating more nitrogen material. And then in this case, we're just directing it right down the street, right to the stormwater, right to Tampa Bay. It is such an easy fix. Instead, just take that downspout, flip it, divert that water to the lawn, to a flower bed, to grass, to trees, whatever the case may be, anything except what we see here. For some reason, I see this a lot in the Tampa area. Reclaimed water irrigation. Again, we've talked about this, and I'll give you some research on this in just a few minutes. But again, reclaimed water has elevated levels of nitrogen and phosphorus in it. So when we irrigate with that, we're adding those to our urban landscapes. This picture here of a lawn, it's really more bare soil than it is lawn. This was under a tree, under an oak tree. And so it's very shady and it's very hard to grow a nice patch of full, lush green St. Augustine sod underneath that shady oak tree. So we end up with, weedy, sort of bare dirt lawn. And the picture on the right is just adjacent to that lawn. It's what the curb and gutter system looks like in the street. And you see how full of soil it is. So that's just soil that's eroding off of that lawn that doesn't have a very good landscape cover on it. No vegetation, no turf grass, no shrubs or anything like that. And so the soil is eroding off and collecting in the street. That soil is a source of nitrogen and phosphorus, particularly phosphorus. There's a lot of phosphorus bound to soil particles in Florida. And so every time it rains, it just flushes that material down that curb and gutter system to the stormwater pond and then on to Tampa Bay. And I always tell people I'm more afraid of that bare dirt lawn and what it's doing for nutrient pollution in our communities than I am for people putting down fertilizer, because I know how much nutrients are in that soil that's being washed down the street. Easy solutions here. You guys are all landscape personnel. I know you probably are thinking 5 different solutions right now, or if not more. It doesn't have to be turf under that shady tree, but we need some type of cover to protect that soil so it doesn't wash away. This is supposed to represent just compacted bare soil, so it's really compacted. And we see that a lot in urban communities. We come in and we build houses really fast and all that equipment that's moving over, and we bring fill material in to make an urban lawn. And then we just end up with crappy urban soils that don't infiltrate water. So again, every time it rains, things just wash away. Solutions to this, incorporate mulch or organic matter into that construction site before we put the turf down. You know, a lot of times when we build a house, it's got these compacted, crappy urban soil. We slap some turf on it. We sell the house really quick. The homeowner moves in. 2 months later, that turf looks awful. And what do they think? Oh, I need to water it. Oh, I need to add some fertilizer. It's not really the case. The problem is it's really compacted, awful urban soil. And if we can, before we put the turf down, before the homeowner moves in, let's incorporate some compost, some organic matter, and work that soil in a little bit so that we can have a better chance of having a good stand of turf on it to protect it. Pet waste again can be a source as well, and leaf litter and grass clippings that accumulate on the streets. You know, certain times of the year, those live oak trees in Florida produce all that leaf litter, and definitely that is a source of nutrients for us. And I think I've got some research slides to show on that in just a few minutes. So anyway, lots of things to think about, and I'm going to talk a little bit about some specific research that we've done that captures some of these things. The first one I was going to talk about, this was in an urban residential community. This was done in Hillsborough County in the Tampa Bay area. And you see on the bottom right-hand side, it's an aerial view of the neighborhood. And then the map on the left is that same neighborhood, just a schematic of the lots. So the green house lots. And the blue circles on that are the storm drains. So it's a curb and gutter system that collects stormwater. And you know, every blue dot is a drain where stormwater drains down below the street. It's connected all by underground pipes, the blue pipes that are shown there. All the stormwater from these lots in the neighborhood go by these pipes and converge and join up in the pond that's shown there on the left, the blue stormwater pond. And then after that stormwater is in that pond for some period of time, it flows onward to Little Fish Hawk Creek, that is a tributary of the Alafaya River, that is a tributary of Tampa Bay. So again, that idea of connection there. And so this is where the research was done. And there's a picture of that stormwater pond, and that piece of equipment that you see is an ISCO auto sampler for collecting stormwater. And we were collecting stormwater every 15 minutes and analyzing that for different forms of nitrogen, and also looking at what's called the isotopic fingerprint of some of that nitrogen, which is just a way of us fingerprinting where that nitrogen comes from. And I'm not going to go into all the chemistry of isotopes, but just think of it as a fingerprint. So we analyze it, we look for something that helps us get an idea of where it came from. And here's some data from that. So the blue lines at the top are rainfall coming down over the course of a rainy season. We start in June and go all the way to the end of September. Pink lines on the bottom represent concentrations of total nitrogen in that stormwater runoff throughout the season. And you'll notice that the lines are the tallest early in the season, June into about mid-July. And what we're seeing there is called a seasonal first flush. And if you think about it, we've had a dry season, January, February, March, April, May. Everything accumulates on the streets. And in this part of Florida, especially, in February, March, the live oaks drop their leaves, and so we've got all this leaf litter in the streets. It's been sitting there, accumulating during the dry season, and then the summer rainy season starts and starts washing that material down the street into the stormwater pond. And so we see this huge flush of nitrogen early in the season when all of that accumulated street material starts getting washed out, and then it kind of tapers off later in the season. And in this case, when we used isotopic analysis to fingerprint where that big flush of nitrogen was coming from, it was almost completely from this leaf litter material that had accumulated in the streets during the dry season. And it just sits there all year round. And as long as it sits there, it's still got nitrogen and phosphorus in it. And, there's a fix for this, right? Well, we can try to keep that material off the streets. It's a lot of work in some cases to go out there and rake up or sweep up those leaves after they drop every year. definitely worth it, and definitely worth thinking about talking to communities about street sweeping activities and activities that can help remove that material from the streets. And in Pinellas County, for example, does have a county ordinance that encourages people to keep that type of material out of the stormwater system. So it's important to think about that. And I always say, trees are not the bad guy here. Trees are good. Trees do so many good things for our urban communities, but they drop that leaf litter material, and we need to be able to process that somehow besides just letting it flow down the streets. Okay, so I said I was going to stay away from chemistry of isotopes, but here's a slide. I guess I snuck this in. We do use a tool called stable isotope tracking to figure out where nitrogen comes from. And I think I will just briefly, it's basically it's based on the number of neutrons in different atoms of nitrogen. So nitrogen always, 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 or it's not nitrogen, has 7 protons in its nucleus, but it can have different numbers of neutrons. And when this happens, it sets up a situation where we sometimes have nitrogen with 1 extra neutron or 1 less neutron. And because of that, their mass is different. So one will be a little bit heavier than the other. And that sets up a situation where we've learned through years of study that nitrogen from different sources is going to have a little bit different sort of mass signature associated with it. And that's how we fingerprint where it's coming from. So we'll analyze some samples. I'll go out and I'll get some runoff samples or a stream sample, water sample from an urban neighborhood somehow. And I'll analyze it for this isotopic signature and plot it on a graph that looks like this. If it plots in that area at the top in blue where it says NO3 in precipitation, that's nitrate in rainfall, basically. So that's just nitrogen that's naturally in the rainfall. If it plots down there in the bottom, a red corner that says manure and septic systems, that would be an indication that it's coming from things like pet waste or maybe ducks and geese that are pooping in the stormwater pond, or it could be septic systems that are leaking, something like that. There's a corner over on the left side, the sort of bright blue color down at the bottom that says NH4 and fertilizer and rain. And then we've got the green one, nitrate and fertilizer. So we can also see if that nitrogen is coming from fertilizers or from soil, things like that. So again, we just take some samples, we get the values, and we plot them on a graph that looks like this. So these are some of those plots from a recent study. This was in Hillsborough and Manatee counties. This work was done in urban residential neighborhoods. We had 5 or 6 different neighborhoods where we were collecting stormwater samples on a regular basis and just plotting where the numbers fell. And you'll see there's a lot of those dots up there in that top portion that indicate it was from the atmosphere. There's also some dots that are in those areas that indicate it's from soil or from fertilizers. What I want you to focus in on most is the top graph on the left side here. If we take all of our samples and determine, what percent of the nitrogen in that runoff came from the atmosphere versus fertilizers versus other things, this is what it comes out to be. The number 1 leading contributor of nitrogen in those samples was atmospheric deposition, which is a fancy way of saying the rainfall itself. So atmospheric deposition was the leading source, followed by nitrate fertilizers, followed by ammonium fertilizers, followed by nitrification, which is a process in the soil that just produces nitrate, followed finally again by soil and organic matter. Really important here to recognize fertilizers are a source of nitrogen in urban runoff, but they're not the only source. And that's one of the most important messages that I love to share with people, because I think that we focus a lot on fertilizers and forget that there are other sources that we need to think about as well. So as that last slide showed, one of the major sources in this area, and it's true for other parts of Florida as well, is just the atmosphere and rainfall. So I'm going to have just a few minutes here. I'm going to focus on some work that was done on this contribution of atmospheric nitrogen in the Tampa Bay area. And you probably are familiar, I'm sure, with the term watershed, which indicates all of the land that drains a certain body of water. We can also have airsheds. So an airshed would be all of the atmosphere around a place where storms can come from and contribute rainfall to an area. And the circle that you see there on their map, that's the Tampa Bay airshed. So storms can come from any of those areas around Tampa Bay and bring rainfall to the area. And this is important because if it comes from different places, it's going to have different amounts of nitrogen in it. If it comes from over the ocean, it might have a little bit, but if it's coming from, say, Atlanta, Georgia, a very urban area where there's a lot of emissions, a lot of vehicles and factories and things, you can have a lot more nitrogen in it. So that's important, just where the storms come from, first of all. But the biggest take-home point here for you guys today is that we've recognized by studying lots of studies in the Tampa Bay area, this point in the bottom here in red, that nearly 57% of the annual nitrogen load to Tampa Bay comes from atmospheric deposition. And some of that is just rain falling directly on the bay, but some of that is stormwater runoff. So you think about rain that hits the sidewalks and the streets and becomes runoff and then makes its way to the bay. So for the 57%, that's a lot. It's more than half of the nitrogen going to Tampa Bay. It just originates in the atmosphere. It's rainfall that's coming down. And a little diagram, a little cartoon is sort of think about this process. So we've got, a cloud bringing down rain. Process number one there is exactly that. It's bulk precipitation that's sending down rainfall with nitrogen to the urban landscape. Process number two, some of that is intercepted by the urban tree canopy, and that's a great thing. Some of the rainfall it doesn't become runoff because the urban tree canopy captures that. And that's great. That's an ecosystem service that trees provide for us. And one of the reasons that we're very eager to expand the urban tree canopy coverage in urban systems. There's also a process called throughfall, which I don't know if you're familiar with that term or not, but throughfall is the water that moves through the tree canopy and continues on that pathway down towards becoming a runoff or infiltrating into the soil. And as it moves through the tree canopy, it interacts with things in the tree canopy, like the leaves of the trees, bug poop, and insects and microorganisms and all of that other stuff. It can pick up extra nitrogen as it does so because all of those materials are going to have excess nitrogen in it. So throughfall can actually be a source of more nitrogen to the runoff. So we kind of have this trade-off, right? The trees are intercepting some of that rainfall and collecting it and reducing runoff, but they're also sometimes a little bit producing new nitrogen because of all of the things in the tree canopy that gets washed out down to the street below. I'm going to talk some more about that in just a minute. So this is some work that was done recently in the Tampa Bay area from on the dots that you see there in Pinellas County, where we were collecting rainfall and stormwater and throughfall underneath the tree canopy. So we had places where we were collecting stormwater, and we had places where we were collecting just rainfall out in the open, and places where we had buckets to sample water underneath the tree canopy. So we were able to get rainfall just under clear sky, no effect of the canopy underneath it, and also rainwater underneath the trees, so that we could get, so we could see what the throughfall was contributing. There's a picture of our very high-tech sampling buckets. They're basically Lowe's buckets with littler buckets inside of them with a mesh screen on top to keep bugs out and things like that. But we set those out and we're collecting and analyzing for nitrogen over the course of, every time it rained over the course of a couple of months. And so some data here. So the blue indicates this is in this case, this is dissolved organic nitrogen, but it was the same for other forms of nitrogen. Blue indicates the concentration of that nitrogen just in the rainfall. So it's smaller than the other components, but it's still there. The orange is concentration in the stormwater runoff. It's going up a little bit. But the green was concentration of that nitrogen in the through fall. So after it moved through the urban tree canopy, look how much it went up. It's basically the same water that's the rainfall. It's the rainfall, and then it just moves through the tree canopy and becomes through fall. And look how much that nitrogen concentration jumps up for the green bars. And again, that's just because the tree canopy is contributing things like insect waste and microorganisms and dead bugs and whatever else is in that tree canopy. So again, and then there's a nice sort of illustration to illustrate this process of through fall and how it works. And when we took the rainfall and compared it to the through fall and looked at different forms of nitrogen, and you can just compare the two columns here. Again, how much higher that through fall was because of everything that's interacting with in the tree canopy. And again, the message here is not that trees are bad. Trees are great and they provide so many good ecosystem services for us. So think this through here a little bit. That through fall that lands underneath the tree, where does it land in an urban environment? Typically, it lands on a sidewalk or a street or a parking lot. And because of that, it can't go into the soil and be processed by the soil. If it could be processed by the soil, that would be perfect. But then it would not become runoff and be an issue for degrading downstream water quality. But in urban environments where trees have like this much pervious surface underneath them, and then you guys probably see this, and then everything else is sidewalk or parking lot. We're just taking that material and shunting it down impervious surfaces where it becomes a source of really concentrated nutrients to downstream water bodies. So again, the problem is not that we have trees, the problem is that we have streets and sidewalks underneath them. And I really make the plea for more green space under urban trees, because when we have green spaces under our urban trees, then that through fall nitrogen and phosphorus can be soaked up by the soil and the vegetation and not just sit down the sidewalk to become runoff. So that's my plea is you guys as landscape personnel, let's try to keep as much space as we can under urban trees to prevent that process. Okay, so with that, I'm going to shift gears a little bit. So I've talked a little bit about leaves and through fall, the atmosphere. Another thing that I wanted to focus on was the contribution of reclaimed water and nutrients and the importance of really good irrigation practices when you're using reclaimed water. So I'm shifting gears a little bit now. And the title of this part of the talk is Streets Don't Grow. Best management practices for irrigating with reclaimed water. And you can see from this picture, so there's this little triangle of urban green space. And you see the sprinkler heads that are irrigating it, right? But then you see the wetting pattern on the sidewalk or the asphalt there. We're watering as much asphalt as we are grass in this picture. Why are we doing that? Streets don't grow. We don't need to water the streets. But I'm sure all of you see this everywhere you go, whether it's irrigating with reclaimed water or potable water. We have so much wasted water by this process. And that's unfortunate just from a water conservation perspective. But if we're irrigating with reclaimed water, that's doubly unfortunate because that reclaimed water has nitrogen and phosphorus in it. And now we're putting it on the street. So it's flowing down the street and becomes part of the stormwater flow, and again, makes its way out to our surface water bodies, our bays and our coastal waters and our estuaries, where it can cause those harmful algal blooms and those issues that we're concerned about. So I want to just quickly talk about reclaimed water and how it's produced, also known as recycled or reused water. It is former domestic wastewater that has been treated and disinfected at a wastewater treatment plant. And it can then be disposed of. You just dispose of it by dumping it into the ocean or something like that. Or it can be put to some kind of beneficial reuse, sent back to communities and used again, which is really important. We need to do that in Florida because we face water scarcity many times of the year. And reusing that wastewater is a great way to overcome that scarcity. It is produced again at the wastewater treatment plant through the wastewater treatment process. And that process involves primary treatment, where we just settle out all the solids and have a liquid that's left behind. And then secondary treatment takes that liquid and chemically and or biologically treats it some more to remove impurities from it. And sometimes, not always, but sometimes then there's a final step called advanced treatment, where we just further treat it to further remove harmful substances. In Florida, most of our treatment plants have only to secondary treatment. We are increasingly incentivizing advanced treatment in the state, but in most cases, we're looking at only secondary treatment, which does a tremendous job of removing harmful pathogens, things that can make us sick. It removes a lot of nitrogen and phosphorus, but nowhere near all of it. So when the water leaves the wastewater treatment plant, it still has elevated nitrogen and phosphorus in it. By Florida law, reclaimed water is defined as this. It's water that has received at least secondary treatment and basic disinfection and is reused after flowing out of a domestic wastewater treatment facility. Florida leads the nation in reclaimed water reuse. Second to us is California and Texas, but we use a lot of that water, and we've been using it for decades. We do so to supply water to our growing urban population. 1,000 people a day move to Florida. We need to have water for them, and reusing that treated wastewater is a great way to do that. 64%, the big chunk of that pie, is for public access areas in Florida. So this is how we use reclaimed water in the state. 64% of that public access, that is urban lawns and golf courses, basically. So a little bit like maybe schools and urban green spaces, but for the most part, it's urban lawns. And it's something like 600 million gallons a day that we're using just to irrigate lawns and other urban green spaces in the state. There are some constituents of concern, though, that we need to be aware of in that water. One of these, of course, is salts like sodium and chloride and boron, because those are used in a lot of household products, and so they become part of the wastewater stream. And they're not completely removed by the wastewater treatment process. And so reclaimed water, if any of you guys are irrigation techs, you probably have run across this. It can have, a lot of that excess salt material in it that can sometimes clog irrigation lines, can also harm the landscapes, landscape plants, because of those excess salts. And the picture that I have here is a mango tree that's been irrigated with reclaimed water, and those salts have damaged the tree because the mango is very susceptible to salt damage. And so one of the recommendations, of course, is to, if you are irrigating with reclaimed water, be aware of that and make sure that you are planting salt tolerant species in your landscape. Just some basic guidelines for dealing with salts. If you irrigate with reclaimed water, you get that water tested and see what the salinity levels are in it. And again, think about planting salt tolerant species and watch out for things like leaf yellowing, anything that could be an indicator that you're getting some salt damage on your plants. Again, that reclaimed water does have a lot of excess nutrients in it, nitrogen and phosphorus again, and that's not all removed by the wastewater treatment process. And so one thing that would be great to do is if we spent more time thinking about how much nitrogen and phosphorus there is in that water that we're irrigating with, and can we offset some of the fertilizer that we apply to lawns if we're irrigating with that nutrient-rich reclaimed water. I believe that we probably can to some extent, but I would also say that we probably need more research on that and need to really work on that. And I think that would be a great statewide thing for us to think about and work on. Those are just some numbers of nitrogen and phosphorus and reclaim. I think I'll skip that. Briefly, there are also some pathogens that can be in reclaimed water. There are no documented cases in Florida of infection from people working with reclaimed water. But it's former wastewater, right? So there's always the chance that there's still a live, viable pathogen in it. So just out of an abundance of caution, if you work with it on a regular basis, be sure to wash your hands afterwards. If don't irrigate your vegetable garden with it, but if you do or you are, wash those veggies and cook them really well before you eat them. And as a word of caution, when using reclaimed water, and I'm sure in this audience, you all know this, overwatering is overwatering is overwatering. And a lot of times reclaimed is not metered, it's not charged. It's not the case in all parts of the state, but in some areas, it's just free to use as much as you want. And we can see some overwatering problems associated with that. So if you work with the public, work with people that are irrigating with reclaimed water, be sure to tell them you can still overuse it. You still need to be cautious about how much you apply. Or you can see problems like this with your sod, and this just caused by overwatering. And finally, and this is where I want to spend the rest of my time today focusing on, is the issue of overspray and potential nutrient pollution associated with this process. Really important to teach homeowners and help them implement practices that can avoid overspray. This is a pathway of nutrient transport to water bodies when we're irrigating with reclaimed water. And you can look at this picture and imagine if those sprinklers are spitting out water full of nitrogen and phosphorus. Again, this is a great image of how it ends up just flowing down the streets and becoming a source of nutrient pollution for us. And this is a research project done by a master's student I had a couple years ago. He just graduated last year, Dylan Barr. And so we're going to spend a couple of minutes talking about his research. So he had two things that he wanted to focus on. He wanted to know how prevalent is this occurrence of overspray in a residential neighborhood, and what's the nutrient pollution implications of that. So let's focus first on just how much are people overspraying in the first place. I'm not talking about nutrients yet, just how much do they overspray? How much water is lost by this wasteful process? So we went into a neighborhood and he used a drone to take pictures like the ones you see here. So we're overhead when everyone in the neighborhood their sprinklers are running, and there's these wetted patterns on the streets and the sidewalks from the excess watering and overspray. And we took pictures of that wetted area and used some software that allows us to convert a picture to an area on the ground. So with that software, we were able to determine an area on the ground that was receiving this excess wasted water. And then we set up irrigation catch cans within that area to capture all the water that was falling within that area. And the catch cans were graduated, they were like measuring cups. So we were able to measure a depth of water over that area. So now we had depth of water over a certain area, and that will give us volume of water. We took the volume of that water, we analyzed it for nutrient concentrations, nitrogen and phosphorus. And when we are able to multiply the volume of water times the concentration of nutrients in it, that gives us the nutrient load. And by that, I mean like pounds of nitrogen or pounds of phosphorus. So ultimately, Dylan was able to come up with calculations that provided, for this lawn, there were X pounds of nitrogen and X pounds of phosphorus associated with that overspray occurrence when people were irrigating the streets and the sidewalks. All right, so some data here. First of all, how much does this happen? How much do people overspray? From his test, the average overspray percentage was about almost 34%, 33.7%. So in other words, every time someone's sprinklers are running, 34% of the water they're applying is just hitting the streets and sidewalks, just wasteful overspray application. That's a lot of water. That comes out to like hundreds of millions of gallons every day if we extrapolate that to everybody in Florida that's running their sprinklers. Obviously, some people are much better than that. Some are probably worse than that. But on average, about 34% is converted to overspray. We then took the concentrations of nutrients in that water from a couple different places, and you'll see the examples here. And let me just explain what's going on here. So let's look at the far left column here. We've got a couple of different locations where we were collecting irrigation water. Um, Jensen Beach and Harbor Ridge. These were both residential neighborhoods that use reclaimed water to irrigate lawns with. The difference is that at Harbor Ridge, they don't use it right from their treatment plant. It's first blended with canal water. So it's diluted with canal water before it's used to irrigate lawns with. And you see the effects of this in the concentrations of nutrients. So for example, let's focus in on this column that says mean total N milligrams per liter. That's total nitrogen. At Jensen Beach, it was 5.6 milligrams per liter. At Harbor Ridge, it was down to 0.8, again, because they're diluting it first with canal water. So big difference there. The bottom row of numbers is from a different neighborhood that irrigates with groundwater. So it's not reclaimed water. And that was like our non-reclaimed comparison. So concentrations were even much lower in that one because it wasn't reclaimed water. It was just plain old-fashioned groundwater. So you can definitely see a trend there in possible nutrient concentrations much higher in the straight up reclaimed when compared to reclaimed diluted with canal water compared to just groundwater. And then remember how I talked about that calculation that we did where we had the volume of water, we multiplied times the nutrient concentration, and we can get pounds of nitrogen every year. And this is what it comes out to be. It's pretty low for that Harbor Ridge neighborhood that dilutes with canal water. Not a lot of pounds of nutrients that they're adding because they're diluting, and they probably are going to need to continue adding fertilizers to their turf grass in that neighborhood. And the other one, the Jensen Beach, though, on the right side here, that's a lot of pounds of nitrogen and phosphorus that's being added just from the water. 2 pounds per year of NO3, that's nitrate nitrogen, 3.12 pounds of TDN, which stands for total dissolved nitrogen. So total nitrogen per lawn per year is estimated about 3 pounds just from the irrigation water. So definitely something to keep in mind. And again, not only from a nutrient perspective, but just from a water conservation perspective, this idea of overspray is really wasteful. And if we say that on average, everyone in Florida is over irrigating about 34%, that comes out to 305 million gallons a day of water that's wasted. And we don't need to be wasting that water in Florida. We need practices to help us conserve that. So I'm going to wrap up with just some best practices for irrigating with reclaimed water. And these are some tips that you can teach homeowners as you work with them. First of all, just know the composition of that reclaimed water. You can contact the utility that provides it or the wastewater treatment plant that it comes from. They should have information on a monthly basis of the nitrogen and phosphorus content of the water that they send out. And you should be able to get that information from them. So just know the composition of it. Is it really high, or maybe they're blending it with something else before they send it out. So in that case, it's a little bit lower. Secondly, remember the Florida-friendly landscaping principles, especially that principle of right plant, right place. If you are irrigating with reclaimed, you may need to adjust your landscape a little bit because you may need to plant those salt-tolerant species. So just remember the right plant for the right place. Next, and this in my mind is perhaps the most important because this is what's going to prevent that overspray, is keep your irrigation equipment working properly. Go out a couple times a year and do a wet check. Check that entire system. Walk around to that far corner or to the back side of the house that you never see, and see how those sprinklers are working, and make sure that you're not irrigating the streets and the sidewalks. The water is only applied to the lawn, to the vegetated surfaces. And avoid that overspray, really important. Not only is it wasteful, but again, remember that data that we just talked about, where it can be providing, 3, 4, 5 pounds a year of nitrogen to the environment. And if this is not taken up by soil and vegetation and turf and trees, then it just flows down the streets and becomes a source of nutrient pollution for us. So teach homeowners to avoid overspray and help them get those sprinklers set so that you're only irrigating the lawn and not the sidewalks. And again, don't overwater. Even if it's reclaimed, even if it's free, we can still overwater. And we need to make sure that we teach people the importance of not overwatering, even when it's free. So just in conclusion, to wrap up my talk today, again, nutrients in urban landscapes come from many sources. Fertilizers are a source, but so is other things like leaf litter, reclaimed water, just the atmosphere and the rain. Trees provide tremendous ecosystem services for us, and I am absolutely an advocate of increasing our urban tree canopy, but we need to keep pervious surfaces, soil underneath them, under their canopies to soak up and process things like the leaves that fall and the through fall that has excess nitrogen in it. So really important. I am always sad when I see trees with like this much soil around them and then it's sidewalk and parking lot. I would love policy that expands the pervious surface underneath tree canopy in our urban areas. Also, research showing that about 34% of applied lawn irrigation is wasted as overspray, which can have both nitrogen and phosphorus in it. So teach people best practices for avoiding that and help do all of those things that can protect our downstream water quality. And that's it. I'm going to wrap it up. And John, I'll let you take over and see if we have any questions.
Thanks, Dr. Lusk. It was a great presentation. Let's see, folks, if you've got anything that you want to ask, you can either throw it in the chat or you can also just unmute yourselves and like ask directly too. So I got a question about the through fall. How much of a difference is there between I mean that was a pretty significant amount of nutrients that can be passing through the trees. Like is there and I know that like you've looked at the impermeable surfaces and where that's definitely like the worst case scenario, but how does like turf compare to mulch to maybe like bare soil, bare mineral soil? Like, is there, and I mean, I guess in terms of being able to process the nitrogen and phosphorus that might be coming from those trees, like, is there been any work on that?
There hasn't been in urban landscapes. There's been a lot of work done with tree fall in forest. What happens to it in forest. But as far as I know, nobody's tracked that in urban landscapes. And I would love to look at that. I think in answer to your question, I think the best case scenario would be it's falling in some sort of surface that's got something growing in it, it'd be low shrubbery or turf grass, because that's going to take up some of that nitrogen in the plant, right? But even if it just hits bare soil and is able to infiltrate the soil and move down through the soil is going to process that some too and capture some of it. So in my mind, even some mulch or something like that would be better than just a sidewalk or a parking lot. So, yeah.
Yeah. So yeah, anything that can soak it up and potentially process it a little bit. Okay.
Yeah. Yeah.
So
I have a question.
yes, please.
This is John from Ralph Taylor's Nurseries. So I was speaking with Brooke Moffis about this, but I'm looking to see, do we have any studies, anything that we can cite right now about the soil amendments? You brought it up that compost going into turf grass areas, but also to your point about the through fallen trees, potentially plant beds underneath, the quality of the soils and their ability to, retain that water. Because it sounds like the number one way to make a difference is to keep the water from making it to the retention pond in the first place.
Yeah, that is nail on the head. I should have said that. The whole 45 minutes that I spent, that was the one sentence summary that you just said, which is nail on the head. Just keep it from flowing to the retention pond in the first place. You're right. And in answer to the first part of your question about studies on the compost and the soil amendments, I do have a colleague in Gainesville who has done some work on that, Eben Bean. I don't know if that name rings a bell to you. He has some work that he's done on that, and if you wanted to just shoot me an email, I would be happy to forward it to him so that you guys can have a conversation. He's got some good data on that. And I think that's part of the work that he's trying to do is just get that message out of how important it is to improve those soils so we can just get good infiltration in the first place. And yeah, so there's a little bit, but we definitely have a lot of work to do. I would love to see us continue to do a lot of work on that.
Thank you.
So I don't know, this might be um a little bit out there, but I think you kind of mentioned at like the major contributors, like in urban landscapes, like is there like a really good percent breakdown anywhere, um, based off of like the major sources of, I know like fertilizer's probably like way at the top of the list, but like where does that fall typically like relative to like pet waste and things like that?
Yeah, that's a good question. And it varies a little bit by location. Um, it's hard to give a general number for like the whole state of Florida. It's hard to say like, oh, 30% is pet waste and 50% is fertilizers. It's hard to give a general number. But we do have some localized studies. So if you know Lisa Krimsky, she led a study in Martin County, I want to say a couple of years ago. Um, it was somewhere in the Indian River Lagoon area. If you look up her work, I was a co-author on that. So look up her work. She did a really, really cool study. They were taking, I should have talked about it here. They were taking water as it ran off of canal front lawns in the Indian River Lagoon. And so it was just like a long, 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 long canal. And we were collecting water right there as it ran off the lawns into the canal, did the isotope work to try to figure out, what was the breakdown, what was the percentage breakdown, just like you were just saying. And in this case, off the top of my head, I want to say fertilizers were like maybe 30%. There was probably another maybe 40, 50% again that was atmospheric, just rainfall. And then there was a good maybe third or almost a third that was just legacy nutrients in the soil. So just and and she did her study like she took samples during the fertilizer ban season and during the not fertilizer ban season. And there really wasn't any difference because there's so many nutrients, like just kind of legacy nutrients in the soil, and it doesn't really matter what time of year it is. It's just it's always going there's always going to be some source of nutrient in the runoff. And so that was a really good study. And again, if you haven't seen that paper, shoot me an email and I'll send it to you. Um, I would say from all the studies that we have done in the state, it's generally it's almost kind of like a third, a third, a third breakdown. Atmospheric fertilizers and soil organic leaf material are always kind of those three top contributors. And I don't argue that we need to use fertilizers wisely. 100% we do. But I feel a little worried when we pass fertilizer ordinances and say, well, we took care of that problem because we didn't, because there are other sources. And yeah.
Cool. Yeah, I've got another question here in the chat, a couple of them here. So the South Florida drainage canals, so these are without reclaimed water added in urban areas, have some nutrient levels as the groundwater.
Do they? Is that the question? Do they?
Yeah, I think that's kind of what they're getting
Oh,
at.
okay.
Do
Yeah.
the drainage canals like have the same level as the nutrient
Yeah.
levels in groundwater?
It's going to be a little bit elevated. Definitely will be elevated compared to groundwater. I don't have a lot of data on that. I don't know if anybody has gone through and really extensively looked at some of those canals, but one little study that we did do in the Indian River Lagoon area, again with some of those canals, um, it wasn't huge, but it was elevated compared to groundwater. Yeah.
Cool. And then we get another one here from Henry. do you think that the fertilizer blackout period could help reduce the phosphorus concentrations?
Well, probably doesn't do much for phosphorus because most of our Florida turfgrass fertilizers do not have phosphorus to start with anyway. And so that's the first reason why I think the blackouts probably don't do anything for phosphorus. Secondly, I don't think they do much for phosphorus because um, phosphorus is really tightly bound with soils. And so it's naturally present in our Florida soils, and it's naturally very inclined to have an affinity for our soils and stick around. And so I think we can stop fertilizing all we want, but for years it's going to still be there in our soils, and um, we're going to still be dealing with it. I think there's a role that fertilizer ordinances can play in preventing nitrogen runoff. But again, there's still sources of nitrogen, other sources of nitrogen as well. So again, I hate to sound wishy-washy. I don't argue that fertilizer ordinances play a role, but I think their role is much smaller than we like to think it is.
Interesting. Yeah, no, we're all eagerly awaiting like to hear the like the stuff that's coming out from UF and the potential impacts from all of that, like with the whether they're going to extend the bans or all that. So I think that's definitely like where the folks in landscape are this impacts them the most. So well, I think there's we're done for questions here. So I just wanted to like thank Dr. Lusk again and yeah, really really cool. I try to definitely have one of these at least available per year where we have somebody from soils and water and try and make it relevant to the landscape crowd. So yeah, and I guess there's some questions showing up on the chat here. Yeah, we'll have this available for everybody. We'll follow up with an email here. And it just goes to like a YouTube link that everybody will have access to. So thank you again. Awesome work up there. And I mean, and thanks for everything you're doing here to help try and keep the water quality decent within the state.
All right. Well, thanks everybody. Appreciate it.